Okay, good morning, everybody. Let me get some things out of the way here. So I hope you guys are doing well. I want to go to our browser here, and I want to remind people of a few things. But I guess let's see who's here, right? Okay. Good morning to Austin. Good morning to Cindy, Xian Chen, Blanca Hernandez. Good morning. Cassandra Vasquez. Good morning. Uh, Paola Alfaro. Good morning. Jocelyn Rangel. Ileana Magana, Jackie Lugo, Sandra Alacorn, good morning. Catherine Mejia, good morning. And Joanna Linderos, good morning. So I hope you guys are doing well. And I hope you guys looked over some of the things that we did yesterday. Let me show you here on our website here. Okay. As you guys know, I have this online transition. And when we click on the online transition now, what you see here, what we worked on yesterday, the notes from yesterday, right? Probability, multiple selections. These are the things that we started. So we were talking yesterday about, selecting with replacement and without replacement, and we're using the multiplication rule. So anyway, there's the notes, just as a reminder. And then here's a link to the lecture, so you guys have that here. Okay. And what I did, which I said to you guys I would do, you see these examples. These are all further examples on the notes and the lectures. So for the conditional probabilities, um, and I'm going to have to rescan this. I'm getting a new scanner soon, and it has this ugly stripe I'm going to get rid of. And I'll rescan this all. And so that's coming in. So I'll let you guys know. But I still wanted to get it up for you guys. You can still kind of read this, I guess. So these are conditional probability questions with the face cards that we actually went over before the break, before all this madness. So you have here um, the additional examples, and they're labeled 9 through 14. I'm sorry, 16. And I would like you guys to look over those additional examples if you haven't already. I promise you guys that, right? And so we also have here probability multiple selections. And these are the additional examples as well. So this is kind of what we went over yesterday, the with replacement, without replacement. I did the rest of the examples like I promised you guys. And so they're here. So I want to remark, take a look. We got with replacement, without, with replacement, without. And so I did what I said I was going to do. So make sure you double check the work, because we will have a quiz next week somehow. I'm not sure how they're going to do it. We got to have some proctorial software. I don't know. But we're going to see what happens, okay? And that's all I can say at this point. Anyway, so before we proceed, let's see the additional people who have showed. Berenice, good morning. Carla, good morning. Leonardo, good morning. Um, Jessica Ortiz, good morning. Rafael Diaz, good morning. Anna Mendez, good morning. And Cindy, no, as far as I know, we are still live. Okay, we're still live. So, okay, let's go now to a couple of things here. We're in Math 227. I'm going to go to the iPad. Math 227. And we were working on probability and multiple selections. Okay. So let's go down to some of these questions here. These are the ones we did yesterday. We worked on these questions here. And I'm going to continue with this particular note. So we're now going to go to the next portion here. Okay, and if you say here, here's the next portion. Thank you, Sandra. You're awesome too, Sandra, just to let you know. Okay. So notice we now have what? 3 selections: A, B, C. Probably a B given A, probably a C given A and B. So I want you guys to consider this here. This is where we're going to start today. We're going to select 3 items. Now, as you guys know, there's 2 situations to consider. With replacement and without replacement. And I know you guys can't see that. Here you go. So you're going to select 3 items now with replacement and possibly without replacement. We're going to have to determine based on the question. Okay, so let me write down the multiplication rule because it looks a little bit more complicated, but it's not. And let me write it here for you guys here, okay? This time we have A and B and C. Of course, like yesterday, A happens first, B happens second, and C happens third. Because we select them, when they say select 3, we still do them one at a time. So that hasn't changed. Okay. Let me see if I can fit this here. I'm going to try it, but if I fail, probability of A. This is the first probability. We have to find that value first. The next is a conditional probability. It's the probability of A given B. So B happens second, assuming A happens first again, right? This is known since we do this one at a time. So this is what you guys had yesterday so far. But as you guys can see, there is actually now 3 selections. So there's a C. So here's how we write this. We now want to know, what's the probability of C given A and B? Now C here happens third. A and B is, of course, happen first, happen second. But what I want to really emphasize to you guys today, if you haven't noticed, is that the conditions here, the given that after the letter, like here the condition A, here the condition A and B. If you haven't realized this, these are things that have occurred in the past. So these are known, these have happened already. So that's the past. And similarly, we got the past here. This is all in the past. So this is what's going on. Okay, so we're going to try to look at that first example here. And of course, if we go to the worksheet and we say, okay, here it is. I'm going to use a deck question. Now, I apologize. The picture that I have here, it doesn't have the ace, but I wrote down ace is high. So ace is above a king. So take a look at this picture and make sure you notate to yourself that the aces are there and they're above a king. So I'm going to now look at question 17, for example. And we got to read this. It's important, right? So what you're saying here is that if you select 3 different cards at random, what's the probability they are all kings? Now, all kings. Okay? All kings. Now, I want you guys to pay close attention to the question. I'll read it again. You select 3 different cards at random. So we know it's not selecting 1, it's not selecting 2, it's selecting 3. Of course, we do it one at a time. You're selecting 3 different cards. So here's my question to you guys. Is this question with replacement or is this a without replacement question? Because that's a big deal for us. So what do you guys think? Is it with replacement or is it without replacement for question 17? What does it mean to be different if we're going to select different cards? Different means they cannot be the same. Is that right? So if this was with replacement, when you select cards, you put them back in the deck. You don't throw them out the window. With replacement means put it back. So what happens with replacement is there's a possibility you select the same card again. And if it's the same, it can't be different. Let's look at the statement without replacement and being different. To select different cards here, if as we select our cards and throw them out the window, if we have the without replacement, does that guarantee that our cards will all be different? What do you guys think? Without replacement, does that guarantee these will be different cards? And I'm starting to get some of these answers in, right, without replacement. So I see so far, Cindy Chun says without replacement. Joanna with replacement. Jackie Lugo without replacement. Joanna Linderos without replacement. You guys are right. So be careful here. Here's what I mean by being careful. Without replacement here is associated with being different, or I actually said it backwards. Being different means without replacement. So now, all these questions that I have for you guys, 17 to 25, it looks like, this is a without replacement situation. So be careful, be awake when they say different. Yes, different means, again, means without replacement. So you guys want to definitely remember that. Okay, now let's write down the multiplication rule for this situation, because all kings means the following. It means that the first is a king, and the second is a king, and the third is a king. So if they want to know the probability of selecting all kings, that means the first is a king, and a second's a king, and a third's a king. So this means the probability the first is a king times the probability the second is a king given the first is a king times the probability the third is a king given the first is a king and the second's a king. Okay, so we're going to find all these probabilities, and I'm going to remark here that given that these things have happened, this is in the past, this is known, those are the conditions. So we really have, again, three fractions here. Okay? All different. Probably the first is a king, times the probability the second's a king, given the first is a king, times the probability the third's a king, given the first is a king and the second's a king. So this is how we use this. So let's stop and think about this, right? If we go back to our deck of cards, because we have to answer these probabilities. I'm looking at the first one. If we select a card, what's the chance that that first selection is a king? We know from the past. There's 4 kings out of 52 cards. So that's the first selected king. We did the first probability. Now go to the second probability here. We want to know, and if we read this left to right, what's the probability that the second card is a king? This line here means Given that what? We know the first selected card was a king, and this is without replacement. So that first selected king card is thrown out the window. So throwing out a king out the window, because this is without replacement, cards have to be different. That means we have not 52 cards anymore. We got 51 cards. And in fact, we no longer have 4 kings. We threw one out the window. So if we throw one king out the window, that leaves us now with 3 kings, just like yesterday. So if we go back, yesterday, these are the kind of things we did. But now we're doing it with a deck of cards. So if we stop and think now, how is today different? Today's different. We're adding an additional selection because they want to know now. What's the probability that the third card is a king? Given that, now what's in the past? The first card was a king and the second card is a king. This is without replacement. These cards have to be different. So the first selected king and the second selected king were simply thrown out the window. They're no longer there. They're gone. They left the deck. So what do you guys think now for this last probability? And I'll give you guys some time because I know there's a lag here. What's the chance the third card's a king, given that the first 2 selections were kings and they were thrown out the window? What do you think that probability is going to be now? What do you guys think? Anybody have an idea? Cindy, thank you. There's going to be 2 kings left because you threw 2 kings out the window. Since you threw 2 cards out the window and you start with 52, you're left with 50. Thank you. Thank you, Benjamin. 2 out of 50. Good job, you guys. So notice the pattern here. The pattern is you are decreasing by 1 in both the numerator and the denominator. Okay? Good job, Blanca. Good job, Raphael. Good job, Catherine. You guys are right. Now, good job, Erica. So now we go to the calculator because we're going to do, we have to give a numerical answer. So let's give this numerical answer now. I need some space. We're going to write this down here. Okay? We're going to write down the answer. It's getting a little bit cluttered here. So let's go to our calculator. Let's go to the TI here. We're going to enter these fractions here. Okay, so here's what we're going to do first. We're going to enter the first fraction now. 4 divided by 52 times the second fraction. 3 divided by 51 times the third fraction. We extend this to another fraction, 2 over 50. And ladies and gentlemen, we're going to hit enter. Okay, something's wrong. How do we know something's wrong? Is something wrong or is something right? Take a look at this. I thought something's wrong, but it turns out it's right. Anybody know? Do we ever enter everything correctly here? What does this mean? Let me write it down. I got to write this thing down. This is what? 1.809954751. So I'm going to ask you this very important question here because you guys are going to run into this. Tell me, and I wrote this down, is this a correct answer? Why might we think this might be wrong? What was my first impression that we did something wrong here? Do you guys know? I'll give you guys some time because it's a very good question to answer. There's a lag here, so I got to give you guys some time here. What do you guys think? When you first see this, you might think that you're wrong or you're right. I don't know. I don't really know what you'll think. When I first seen this, I said, oh, this looks wrong to me. Do you guys know why it's wrong? How it looks wrong? Thank you, Joanna. Probabilities are between 0 and 1. Okay? Remember this fact. The probability of any event, it doesn't matter what the event is, or events, right? This is always between 0 and 1. So the second you see a probability value that's above 1, or negative even, you know something is not right. It should be a red flag. Now, go back to the calculator and double check, because when I'm looking at your comments, yes, it looks like Joanna Landeros is right. What did we forget to write down? If you take a closer look, and maybe I can put my pointer, I don't know. Let's write everything down. This is E here. If I continue, e to the negative 4 power. Do you guys see that when you read it from left to right? My answer after the 751, I got e to the minus 4. Okay, that's missing. That's part of our answer. So then the question becomes for people is, if they focus on this portion here, I'm going to ask you guys, what does that mean? What that means is this is times 10 to the minus 4. This is really scientific notation here. So when you look at the digits, and let me do it over here. We'll put 809954751. We really don't have to put all those digits. I'm going to do this. The 10 to the minus 4 means move my digits, move the decimal 4 spaces to the left. 1, 2, 3, 4. There's my new location of a digit. Let me do this a little better so we can see this. Move the digit 4 spaces to the left. If it's negative, you move it to the left. 1, 2, 3, 4. And the blank spaces, you fill in with a 0, because this is scientific notation. So what I'm going to do today here, when we approximate our answer, I want to approximate to the nearest 10 what? 10 thousandths. Or maybe we should do 100 thousandths. Okay, so this morning, yeah, let's do 100 thousandths. And now let's do 10. Here we go. 1, 2, 3, 1, 8, 0, 9, 9, 5. It doesn't matter because I go tenths, hundredths, thousandths. Take a look here. There's a 1. I look at the digit to the right. That's an 8. So tell me, let's approximate this to the nearest tenths, 100 thousandths, 10 thousandths position this morning. What's my answer? What digit do I put? Do I put a 1 or do I put a 2? you guys know if I had Flaming Hots to give you, I'd give you them. So yeah, Jackie. Jackie has a good point. Here's Jackie's point. Jackie's saying her calculator actually gave her this representation without scientific notation. Yes, some of your calculators are going to do that. Some of them are going to give you this answer. Some of them are going to give you the answer in scientific notation. It depends on how your calculator is set up internally, to what degree of accuracy that could be tinkered with. Um, so, yeah, if you get this answer, you might say, hey, good, I'm ahead of the game. Yeah. Well, you are. So good for you, Jackie. You got a good calculator, right? But some people are going to get scientific notation like I did this morning. So Jackie has a very good observation. Okay. And Benjamin, you're absolutely right. The next digit is going to be a 2 because this 8 says add 1 to 1, which gives you 2. So now you're right. Benjamin's correct. Catherine's correct. Joanna's correct. Cassandra Vasquez is correct. Here is this approximation. This is a probability value. So this is probability, and I'm going to write here again percent. Move this as a percent, though, 2 digits to the right, and we get 0.02. Let me double check here. 2.02%. This is as a percent. Now, the reason, again, we say, do we give the percent answer to give the probability? Well, they asked you probability, so you give the probability. The reason we have percent is simply because conversation, because anything that's less than 5%, smaller than 5%, now this is much smaller than 5%. This is not even 1%. This is not even 1/10%. This is 2/100ths of a percent. So what that means is the probability here of selecting all kings, it's still possible, but what we say that the event is not likely. So this is less than 5%. It's not likely we're going to select all kings here. Still possible, but not likely. Okay, that's a lot of detail. Okay, a lot of detail to go into what we're just talking about. Now, this again here, we're going to focus it a little bit differently today. We're going to do all this without replacement. And then we could do with replacement. We're going to look at the situation now here where you have all hearts. So this is question 18. I'm going to select all hearts here. Okay, and I'm going to go a bit faster on this time since you guys have been through some of the details. Of course, they're all different. So since they're different, I'll write that here. Different means without replacement. So here we go. This is the probability. The first is a heart. And the second is a heart. And the third is a heart. That's probably the first is a heart. So probably the second is a heart given the first is a heart. The probability of the third is a heart given the first is a heart and the second is a heart. So here we go. We're going to reach in the bag. We're going to start with the first probability. Probability the first selected card is a heart. We know there's 13 hearts out of 52 cards. Okay, the next chance. Probability the second card is a heart. Given the pass, the first is a heart. We selected a heart first. It's out the window. So the chance the second card is a heart becomes 12 out of 51. The next probability. We know the condition here is from the past, the first two selected cards were hearts and they're now out the window. So the chance that the second card is a heart, I'm sorry, third card, we're right here. Given the past, well, what happened in the past? The first two cards were hearts, they're out the window. We're left now with 11 hearts in the deck, and the deck has 50 cards because we threw 2 out the window, 2 hearts. So here's what we're going to do. We're going to multiply here. You get to use our calculator. So at this point, we're going to go, okay, calculator. Let's see what we get. Let's go to the TI now. $13 divided by 52 is that first probability. Times 12 divided by 51. Times 11 divided by what? 50. Close that. See what we get. 13 over 52, 12 over 51, and okay. We lost it. Let's try it again. Let me see if I can get previous answer back. Nope. All right. I don't know what I touched. 13 divided by 52 times 12 divided by 51. Close that. Times 11 divided by 50. All right. Okay, let me write this down. Okay. All right, well, let's take a look at this here. We said today we're going to do the 10,000s. So let's see what happens here. Tenths, 100, 1,000, 10,000. Look at the digit to the right there. Oh, it's a sad eye. Not much better. Okay. So the 9 is in the 10,000s position. We look at the digit to the right, which is a 4. So again, do we add 1 to 9 or do we leave it the same? Stays the same. So Joanna, you are absolutely right. And as a percent, it's 1.29%. So notice, if we move that decimal 2 spaces to the right, that gives us the percent. The event still is not what? Likely to happen. Because anything less than 5% is not likely. It's still possible, small chance, but not likely. And this is how we answer question number 18. Because we're selecting, again, all hearts. Good. What's number 19? All red cards. All red. Okay, let's try all red cards. This is an interesting question. All red. And again, they must be different. And different means without replacement. So if we're selecting 3 cards and they're all red, that means the first is not red. I'm sorry, is red. And the second is red. And the third is red. Using the multiplication rule. Let's write down that bit. Here we go. Okay, this is the multiplication rule. So let's reach in the bag and determine these probabilities. The chance the first selected marble is red, we know how many red marbles, how many red cards are in our bag. Well, we know there's going to be what? 26 out of 52. That's about 1/2. All right, you guys okay with that? Thank you, Michael. Thank you so much. Anyway, Michael's a good guy. So this is without replacement, right? So let's go back and say we did the first probability. What's the probability the second card was red? Given our past is the first selected card is red and it's out the window. That leaves us with 25 red cards now because a red card is out the window. Out of 51 cards because we threw a card out the window. You started with 51. A red card is out. So this is our second probability. Probability the third card is red now. Given the first is red and the second was red from our past and they were thrown out the window. What that means is we have 24 red cards left out of a batch of 50. This is the probability that that third card is red. So, ladies and gentlemen, this is the process here. And what we're going to do is, again, go to the TI, and we're going to find out what these answers are. And let's take a look here. First fraction is 26 divided by 52 times 25 divided by 51 times 24 divided by 50. So I'm going to write down some of those answers, right? 0.117647058. So let's take a look. Remember, we're going to approximate to the 10,000s again. So let's find the digit in the 10,000s position. Tenths, 100,000, 10,000. Look at the digit to the right, which is a 4. What does that mean I do? Do you guys know? Do I add 1 to 6 or do I leave it alone? Since it's a 4, I leave it alone. And here's my probability. Yep, Joanna's correct. So I want to remark and say to you guys that this is 11.76%, just as a percent. So the probability value is 0.1176, but that's 11.76%. And I want to remark to you guys that this is not less than 5%. We don't say that this is not likely. So anything that's not likely is under 5%. This is over. So we just leave the answer as is. Okay. So I want to let you guys know this is how we answer this particular probability. That's the chance when we select 3 cards without replacement. They're all different, right? Of course, we're doing it one at a time. This is the chance that all 3 are red. 0.1176. Great. Good. This is 19. Let's see what 20 says. See if you guys are getting the hang of this. That's the idea. 20, all face cards. All face cards. since they're all face cards, that's a probability. The first is a face card, and the second is a face card, and the third is a face card. Let's remember, being different is without replacement. Probability of the first is a face card times the probability of the second is a face, given the first is a face. The probability of the third is a face, given the first is a face, and the second is a face. And I know you can't see, but now you can. So here we go. So here we have to remember, see if you guys even remember, we're going to do that first probability. What's the chance that the card you select is a face card? See if you guys recall, since before we actually left, right? What are face cards? And this is an F for face card. A face card is a card with a face. It has to have a face. So if we say which cards have faces, right? Let me go back to that sheet. If you guys remember, which cards have faces? The jacks, the queen, and the king. They all have a face. It's like a person. It's a person's face. That's what it means by face card. So I have 4 types. I have clubs, I have spades, I have diamonds, I have hearts. So for every type, there are 3 face cards, the jack, the queen, and the king. So 3 plus 3 plus 3 plus 3, or 3 times 4, is going to be what? How many cards are face cards again? Cards with human faces. The answer is 12 cards. 12 out of the 52 have faces. Now, to ask the second question, what's the chance the second card is a face card given the past? What happened in the past? What happened in the past is you had a first card that was a face card. And we threw it out the window. So the chance the second card is a face card, if one face card is out the window, there's 11 left out of 51 cards because one card was thrown out the window, a face card. The third, probably the third card is a face card. Given your past, the first is a face and the second is a face. That's our past. Well, we threw 2 face cards out the window. So if we started with 12 and 2 are gone, we're left with 10. If we started with 52 cards and we threw 2 face cards out, we got 50. So this is what we do, ladies and gentlemen. This is the process. Notice, yes, you say, Mr. Judge, it looks like things are decreasing by 1. Yep, they are. So, of course, at this point, we need to know. And Raphael, you looks like you're absolutely right. Here's what we're going to do. We got to put this in the calculator again, right? So 12 divided by 52 times 11 divided by 51 times 10 divided by 50. Here we go. So we get 0.0099547511. This is what our calculator says. Now, we're going to need to see what this is if we approximate our answer to the nearest 10 thousandths again. So let's see what you guys do. Let's find out, right? Tenths, 100, 1,000, 10,000. This is a very good example. This is an example where people ask questions. So we had some very good kind of questions here today with some good answers. So here's what we're going to do. If you guys remember, because the digit to the right of the 9 that's in the 10 thousandths position is a 5. What that means is we add 1 to the 9. Okay? Just because the digit's a 9 doesn't mean anything. We get to add 1 to that 9. And this is what I'm talking about. The digit in the 10 thousandths position, we have to add 1 to that. Now, look at what happens when we add 1. I'll keep it in red. You guys know, what's 9 plus 1? 10. Carry the 1. What's 9 plus 1? 10. Carry the 1. What's 1 plus 0? 1. Bring down the next 0. And ladies and gentlemen, guess what you get? An answer to the 10 thousandths position is really 0.001. And then you say, but Mr. Judge, oops, I wrote it down wrong. It's 0.01. You say 00, right? And then you say, but Mr. Judge, do I need to write down the last 2 zeros? And I'll say, no, you don't. But then why is this answer now in the hundredths position and we're trying to approximate in the 10 thousandths position? Well, it's because of this approximation of adding the 1 and the effect here of the calculation. So if you said, can I just write my answer as 0.01? Yes. Some people feel a lot more comfortable by adding the extra zeros, although they're not necessary. They're not necessary. Those last 2 zeros, remember, you can put as many zeros as you want. It doesn't change the meaning of the decimal. So either way, you're good. If you really want to be impressive about it, though, I'm going to say to you guys, I accept either answer personally. But if you're looking back at the book, actually, let me take it back. If you're looking back at some books, they actually have both. So I want to show you guys here, this is how we handle this situation. And it's a very, very, very good example. Anyway, okay. That's question 20 now. And question 21, let's look at our time. 21, they're going to be all, let's see what we can do. They're going to be all cards less than 4. Let me try that one. So that means, since we're selecting 3, the first is, I'll put Al for less than 4. And the second is less than 4. And the third is less than 4. That's the chance the first is less than 4 times the probability the second is less than 4. Oops, let's do the condition. Given that the first is less than 4 times the probability the third is less than 4. Given that the first is less than 4 and the second is less than 4. Okay, and I know you can't see, but now you can. All right, let's get this out of the way. So by now, you guys can have some good intuition about how this works, right? So the first probability, the chance you select a card that is smaller than 4. And again, they're different, so this is without replacement. go back to the deck. Not only go back to the deck, recall that the ace is high. So since the ace is high, as we've been looking at, as you guys know, that's counted as higher than a king. So being smaller than 4, less than 4 is strictly smaller than 4. So which cards are smaller than 4? The 2 and the 3. Is that right? 4 is equal to 4. Don't include 4. People do, but don't do it. Less than 4 is strictly smaller. There's only 2 cards, assuming the ace is high. That means the 2 and the 3, which are less than 4. So we say 2 plus another 2 plus another 2, or 2 times 4. What that means for us is that there are 8 cards out of 52 that are less than 4, assuming the ace is high. If the ace is low, ladies and gentlemen, and sometimes I do that, they're going to tell you that the ace is low. Now, when the ace is low, you have to include the 4 aces, and that would change your answer to 12. So if the ace is low, it's 12, but the ace is high here, that means it's going to be 8. Okay, good. This is why I wanted to get to this question. And the rest, as you guys know, if you can see that pattern, you might suspect, and you might say, oh, Mr. Judge, can I just decrease things? Well, let's see. 7 out of 51 and 6 out of 50, right? So the second probability is the chance you select a card that's less than 4, given the past. And in the past, the first selected card is less than 4, and it's out the window. So I get 7 out of 51. The next probability is the third is less than 4. And what do you do here in the past? We selected a first card that's less than 4 and a second card that's less than 4. They're now out the window. So yeah, we now have 6 cards less than 4 out of the 50. So yes, it's going through the same exact pattern. And if we go to the TI-84, as you guys know, let's compute this. Okay, let's find out. Parentheses, 8 divided by 52. Close that. Times 7 divided by 51. Close that. Times 6 divided by 50. Close that. Let's see what you guys get. Here's our answer. 0.0025339 and so on. And I know you can't see, but you will in a second. Here we go. Double check your calculators. Okay? So remember, we're going to approximate this to the nearest tens, 100,000, 10,000, and we look at the digit to the right. So our answer is going to be approximately 0.002. Now, what do we do with the 5? Do we add 1 or do we keep it? Since the digit to the right is a 3, we leave it alone and we keep the 5. We don't add 1. Similarly, this is actually 0.25% as a percentage, which means this event is not likely again. Okay. Now, looking at the questions here, right? Got a few questions. I think Cassandra has a question, and she's saying here, right? She's saying here, why the 8? It's a very good question again. We got to go back. Why the 8? So let's go back here. And let's remember, cards less than 4 are strictly smaller than 4. Okay? Smaller than 4. So, which cards are smaller than 4? Oops. Let's go to the cards. Cards smaller than 4. So I'm going to write this down here. Less than 4. If I move it. What does that mean? It's the 2s or the 3s. We do not include 4. So what that means is there's 2 cards smaller than 4. However, we have 4 types. You say, what are the types? The first row is clubs. The second row is spades. The third row is hearts. And the last row is diamonds. So what we do here is we multiply 4 with that 2. And that means that they are 8 cards that are simply smaller than 4 because we got 4 types. And that's how we got the 8. Okay, you guys okay with that one? And again, this is assuming that the ace is high, which means we don't count the ace. If the ace is low, that's below a 2, like thought of as a 1, and then we would count it, and that makes this now 3 cards, and then 4 times 3 will be 12. So are we okay with that, Cassandra? Do you see how we got the 8? Okay, now I'm getting to a question I want to get to. None are kings. So I want to start to focus here on, and this is question number 22. Okay, it's important. None are kings. Okay, we have to know what that statement actually means to have none are kings. And none being kings means the first is not a king, and the second is not a king, and the third is not a king. That's the probability. The first is not a king times the probability. The second's not a king, given the first is not a king. Probability the third is not a king, given the first is not a king, and starting to get weird out there. Let me move the iPad. And the second is not a king. So here's our selections again. First is not a king, second's not a king, third's not a king. So we have to know, what does it mean to not be a king? So the first question is, what's your probability that the first selected card, a selection, is going to be a non-king now? Not a king, but non-king. And there's a lot of non-king cards. The queens are non-kings, the aces, the tens, the nines, and so on, the 2. So if you guys remember by the complement, right, if the chance you select a king is 4 out of 52, the chance you select a non-king is 48 out of 52. If there's 4 kings, there's 48 non-kings. It's not a king. 4 kings gives you 48 cards that are non-kings out of the 52. And again, this is without replacement. And yes, Cassandra's correct. Catherine's correct. Good job. So we go and we say, okay, what's the chance the second selection is a non-king given the past, given that the first selected card is a non-king? Well, the chance the second card is a non-king, how many non-kings are in the deck now? What do? We threw a card in the first selection out the window. We threw a non-king. So if we start with 48 and a non-king is gone, that leaves us 47. 47 cards that are non-kings. Remember, we threw a non-king out the window. So that's going to be out of 51 cards. And so as you guys can see in great detail here, when we try to find the probability that the third card is a non-king, given your past, that the past 2 cards are non-kings? What's the chance that that third card is a non-king? And you say, what did we do? The first 2 selections were non-kings and they're out the window. So if we start with 48, we now have 46 non-kings. If we started with 52 cards and we threw 2 non-kings out, we got 50. And we do have Catherine Molina. Absolutely. You do have the correct answer. So I want to demonstrate that. This is correct. Okay, good job, you guys. All right. And yes, Benjamin, let's take a look at you here. That original question you gave, the original answer, 52 minus 4, that's the complement for the first probability. Benjamin is also correct. So good job for you guys. Okay, now you guys know, doesn't the pattern continue? It's countdown 48, 47, 46, 52, 51, 50. That countdown continues. So we go to the calculator and try to find the answer here, the TI. Okay, so let's clear that up. Let's find these answers here. 48 divided by 52. Let's close that. Times 47 divided by 51. Let's close this. Times 46 divided by 50. Let's close that. Let's see what we have here, okay? This is the answer in our calculator. And of course, we're going to answer this question to the nearest tenths, hundreds, thousand, 10,000. We look at the digit to the right. So the digit in the 10,000s position is the 6. But the question is, do we add 1 to the 6 or do we leave it alone? The digit to the right is a 2. So that means we leave the 6 alone. And you're done. So ladies and gentlemen, here you guys go. This is a non-situation. And I wanted to get to that because you do see a bunch of these non-situations. It's going to be important for us in our future to know about this non-king. So that's why on the worksheet, if we look at this, some additional questions that I've given on the worksheet. If I can get it, there we go. Okay, there it is. Let's put it off to the side here for us. Okay, you start to see from question 22, the first none are kings. 23, none are hearts, none are face cards, none are cards less than 4. Those are now the non situations for the ones you did above. And I want to also point out, I asked you from questions 26 to 34 again to do this process, but you're going to do it with replacement now, with replacement. So you're going to put together the ideas we talked about yesterday and today to do that, of course, on your own. But let's continue. Let's try to get another one in here, right? 23. So you guys can see what you have to do. And of course, I'm going to put some more examples from this worksheet for you guys to look at. And but let's try to do 23 now, right? Let's see if we can get this. None are hearts. Probably the first is a non-heart. And the second is a non-heart. And the third is a non-heart. That's probably the first. And I'll just put a little n. You don't have to do a capital N. Chance the first is a non-heart. Remember, we're writing down the multiplication rule. Okay. So we got this multiplication rule here to consider, just like before. Let's see if we could kick this one out now. So let's think. We reach in the bag. We want to know what's the chance that that first card is a non-heart. Well, we got to think about that. If we have 13 hearts in the deck, there's 13 hearts out of the 52 cards. 13 are hearts. That means 52 minus 13 are 39 cards will be non-hearts. And again, that's out of 52 cards. 39 hearts out of 52 are non-heart cards. 39 cards, sorry. 39 cards out of 52 are non-hearts. And as you guys know, the chance the second card is a non-heart, given the first card, the past, given our past is a non-heart, is thrown out the window. There's 38 out of 51 cards that will be non-hearts. For the third selection, given our past, we selected 2 cards that were non-hearts. They're out the window. We're left with 37 cards that are non-hearts out of now 50 cards. So yes, your countdown continues for this non-heart situation. Non-hearts. All right, now let's see. Let's see what this means in terms of our calculator. So remember here, and I'm going to put that in the notes, this here is without replacement. And that's an important detail because they're supposed to be different. And we got to see what this is numerically to the nearest 10 thousandths. So going to our TI now. TI. Okay, TI. 39 divided by 52 times 38 divided by 51 times 37 divided by 50. Here's our answer. Okay. Both Catherine and Joanna are correct, I guess. Let's see. Remember, we're going to the nearest 10,000. So let's see. Let's see what we get. Sorry, I'm trying to bring this in here. Okay. Oh, I know. I apologize. Here we go. Now we're better off. So let's see. See if we're correct here with these answers, right? Going to the nearest 10 thousandths. So tenths, 100, 1,000, 10 thousandths. The 5 is there. We look at the digit to the right. And so what this means is we leave the 5 alone. Okay? We leave that 5 alone. I don't know why that is there. Let me undo that. Okay. All right, so let's go back and see that. It looks like 0.4135. Looks like both Catherine and Joanna are correct. Okay, good for you guys. So you're starting to get the knack of this and the handle, how to handle these situations. Again, it's important. And this is interesting because, you know, we don't have to do heavy mathematics at all. All we got to do is keep track of our cards, keep track of our marbles. Okay, everything you ever had to learn from this kind of process, you can learn from cards, or or even a bag of marbles. So, we do got a few minutes here. Let me double check here, see if we want to try this here. None are face cards. I mean, I can try to see if we can answer that kind of question, or leave this to some of these here. Leave this to our examples, right? Remember, I'm going to do that. That's the route I'm going to take. So let's kind of regroup and recap here. Our start of the day here, going back to our browser and showing you guys that we do have the lectures online. So what I'm going to do for probability multiple selections, I'm going to put the YouTube link below here. And for that first lecture, or the second lecture yesterday, I put some examples. So what I'll do is below here, I'll put the part 2, and I'll put the additional examples. So I want you guys to, and I'll do that in writing, I'll PDF it and upload it. I believe I gave you guys your homework yesterday. Is that right? So give me a few seconds here. I'm going to do the following. I'm going to get your book work. Remind me. See if you guys have the book work. Looking at the book work, I gave you web work yesterday. But book work is good too. So you guys are going to have all these examples. I know Raphael says, yes, you're right. I'm going to go back and look at this book work, because I believe I gave you that book work of 4.3. And 4.3 has some very interesting questions. Thank you, guys. I'm glad you guys are up to date on that. They have interesting questions. So, I have some ideas that I'll notify you guys with regarding this. Thank you, Cassandra. You're right. You have that. I have some other ideas that I'm going to kick around, but I want you guys to make sure you start working on that book work and the web work, and I'll put these things online for you. Cassandra does have it right. Let me get this from Cassandra. Let me remind you guys. She does have it right. Okay. This was from the book work that we assigned on conditional probabilities, and I think there's some multiple selections there. There should be. But I also have the web work. If you guys remember, web work. What was the web work? Let me go back here. Elementary Statistics Video Library. This is yes, Raphael's correct too. So let's bring Raphael in. Okay, Raphael's also correct. So, we got statistics lecture 7, and you guys can see I have it in the middle of the page here. Maybe I should blow that up. There we go. Let's blow that up. Bring it down, I guess. There we go. So we have statistics lecture 7. So again, if you guys want to watch this lecture again, you get to. It's on my website. All the details here about multiple selections with and without replacement. So you have all the resources. The web work, if you guys remember here, is these items. So we do have some conditional probabilities, and there should be some multiple selections. See, here's some card questions. So you got plenty of examples about how to do this. You got plenty of work. Practice makes perfect. And again, if you guys remember, if you ever have a question here with this worksheet, go back to the corner down here. Do you guys remember? I know it's going to take some time to reload, but go back to the corner here. There's the video solutions for the odds. And up here, Statistics Lecture 6, we had conditional probability worksheet. And if you get stuck, video solution again for the odds here. So let me just remind you guys here. Worksheet, video solutions for the odds. Worksheet, video solution for the odds. And we're going to talk about at least one next time, and that will conclude, when we do that, the Statistics Lecture 7, because you have to know how to do these things before you go to at least one. And, so that's what's going on. So I'm leaving this up at the moment with Cassandra and Raphael. That's your homework, because sometimes people will even contact me and say, Mr. Judge, what's the homework? I don't remember the homework. Well, take a look here, right? This is your homework. And so before we sign off, and I want to remind you guys, I do have office hours. And when do I have my office hours? From 10:30 to noon, and I have them in Canvas. So I'm also here for that. Next week, you'll have your first quiz. I'm not quite sure how we're going to do that. There's a proctoring software that's out there, so I'm not sure how they do this. I'll find out, though. Hopefully, we'll find out this weekend. But the school's supposed to get that for us. They say they have, but we have to learn how to use this. So I don't even know yet. But we're gonna when we find, excuse me, when we find out, I'll let you guys know. And we're gonna play it by ear. We're gonna take it easy. We're just gonna relax in this. So if you guys have any questions, I know there's a lag here. Let me know. Oh, Catherine, good. When are we taking the next exam? That's your quiz next week. So remember to study. Okay, the quiz next week. Blanca, yes, you could do the odds. Okay. So yes, you guys, you could do the odds. I understand. You have all the resources here if you need to look it up. Okay. Anyway. So I hope you guys enjoyed the lecture today. I want to thank you guys. We have 17 people left. We had more earlier. I want you guys, remind you guys, don't touch your face. Okay. Wash your hands. Virus gets killed with soap and water very easily, but you got to put that at least 20 seconds of soap and water for your hands, and don't touch your face with dirty hands, So stay safe. And I'll see you in office hours, okay? Have a good weekend, okay? You guys take care.